Hello Year 7, today we're looking at Venn diagrams and two-way tables. So the first spaces in here to fill in is a two-way table lists the number of outcomes or people in different categories, with the final row and column being the total of the other entries in that row or column. So I'm going to make up some numbers to put in this table here. So I'm going to say that there are 10 people who like math and they like English. There are 2 people who like English but do not like maths, and that makes a total of 12 people that we've looked at so far. Of the people who like maths, we've already got 10 that like English, but there are 6 people who like math but do not like English, so that makes 16 people here. Okay, now I'm going to say that there are 7 people who do not like maths or English. And then when I add those two together, 2 plus 7 means that there are 9 people that go in that total there. If I add across this row, 6 plus 7 makes 13 to go in that total. And to find this last square here, you can add either way. So either you go 12 plus 13 to get 25, or 16 plus 9 would also give you 25. Okay, so that's some made up information, but that is how you have numbers in your two-way tables. So we could put that information into a Venn diagram. So Venn diagrams allow a pictured representation of a two-way table. So if I take that same data, each of these circles is going to represent one of the subjects. So this first circle is going to be for maths, and the second circle is going to be for English. Now, this overlapping section of the two circles is how many people liked both maths and English, and there were 10 people who liked maths and English. Okay, then this part of the English circle will be people who liked English but didn't like maths. So like English but do not like maths, there was 2 people. This part of the maths circle is people who like maths but not English. So like maths is here, do not like English is 6 people. Okay, then there is often a number that is outside the 2 circles. We write it out here on the corner, which is people who do not like maths or English. So this 7 here, we write that down here, 7. So people who do not like either is 7 people outside of those 2 circles. Okay, so we have the 2 different ways of showing the data. We have the two-way table and we have the Venn diagram. Now, moving on to the next part. Mutually exclusive events, so write that in here. Mutually exclusive events cannot both occur at the same time. So for example, rolling an even number and rolling an odd number on a dice. Okay, so if we have our dice, we have the even numbers for this circle and we have the odd numbers for the second circle. There are 3 even numbers on a dice and there are 3 odd numbers on the dice. There is no overlap of those 2 circles because there is no numbers that are both even and odd. A survey is conducted of 50 people asking who likes coffee and who likes tea. It was found that 20 people liked both, 15 people liked coffee but not tea, and 10 people liked tea but not coffee. How many people liked neither tea nor coffee? All right, let's try and put some of that information onto our diagram. So of 50 people, Okay, that's important. There's 50 people in total asking who likes coffee and who likes tea. So let's make this the coffee circle, and this is going to be the tea circle. It was found that 20 people like both. Okay, so the 20, that's going to be here in the overlap because there's 20 people who like both. There were 15 people who liked coffee but not tea. Okay, so 15 people liked coffee, not tea. That goes in here. And 10 people who liked tea but not coffee. So 10 people liked tea but not coffee. So it looks like I have all the numbers in the circle, but I need to know if there's anything that comes outside of these circles. Now remember that I have a total of 50 people. Let's add up the numbers that we've got there so far. I've got 15 plus 20 plus 10. So those circles only add up to 45 people. That means that there must be 5 people out here that do not like either tea or coffee. Okay, so answering part A, how many people liked neither tea or coffee? There is 5 people who didn't like tea or coffee. Part C, how many people surveyed like tea? Well, that's everything that's inside the tea circle. Yes, some of those people liked coffee as well, but there is 30 people who liked tea inside that tea circle. How many people liked both coffee and tea? That's the overlapping section. There is 20 people who like coffee and tea. And how many people like coffee or tea or both? So they can like coffee, they can like tea, or they can like both, adding all of those up. And we did that on the calculator a minute ago, and we saw that that was 45 people. Part F, represent the survey findings in a two-way table. So we want to translate that data into a table here. So we need to put some headings on here. I'm going to call this one like coffee and dislikes coffee. Okay, this is going to be the total column here at the end. Then on these next ones down here vertically, we're going to have like tea and dislike tea. And down the bottom we will have the totals again. So let's fill in the numbers. This first box here is people who like coffee and like tea. That is the 20, that's our overlapping section. Then we want likes tea but dislikes coffee. Likes tea but no coffee is the 10 people, which means a total of 30 people for that first row. Then we want likes coffee but dislikes tea. So dislikes the coffee but no tea would be 15 people. Dislikes coffee and dislikes tea is the people that don't like either at the side here, the 5. If I go 15 plus 5, I find this total here is 20. Then I can add vertically 20 plus 15 makes 35. And 10 plus 5 makes 15. And if I add 35 and 15, or 30 and 20, either way I add, either going across the bottom or vertically there, I get 50 for the total number of people in that two-way table. Okay, next. Consider the two-way table below showing the eating and sleeping preferences of different animals at the zoo. So a table is provided for us. We want to find, for a randomly selected animal, find the probability, so P for probability, that it sleeps only at night. So sleeps only at night is here. We want to know how many animals sleep only at night. Well, that would be this total here. There is 68 animals that sleep only at night. So 68 out of, what is the total number of animals that we've been surveying in here? There's 100 animals in the total here. So it would be 68 over 100, and then we would need to simplify that. So 68 over 100 equals 17 over 25. Part 2, we want the probability that it eats meat or sleeps during the day. So let's have a look. Eats meat. There are 60 animals that eats meat, and we also want it to sleep during the day, but it has to sleeps during the day, but we've already counted these 20 that eat meat here, so we just need to count the extra 12 that sleep during the day but don't eat meat. So altogether we have 60 plus 12, that is 72 animals that eat meat or sleep during the day out of 100, and we use our calculators to simplify. So 72 over 100 equals 18 out of 25. Part B. If an animal is selected at random and it eats meat, what is the probability that it sleeps during the day? So we're only interested in the animals that eat meat. So there are 60 animals that eat meat. That's my total. Of those 60, I want to know how many of them sleep during the day. And there is 20 that sleep during the day out of that 60. So we can write that down as probability that eats meat and sleeps during the day. Okay. So that means there was 20 that sleep during the day out of the 60 that eat meat, and we simplify with our calculator. 20 out of 60 is 1/3 of the animals. Finally, what is the probability that an animal that sleeps during the day does not eat meat? Okay, so this time we're interested in the animals that sleep during the day. There is 32 animals that sleep during the day. What is the probability that it sleeps during the day and does not eat meat? So no meat means 12. So the probability, you could write it out in words, but I'm just as happy for you to write the fraction straight down. The probability would be the 12 that do not eat meat out of the 32 who sleep during the day, and simplify. So 12 out of 32 simplifies to 3 out of 8.